today I'm going to be discussing Core 9 and the law of cosines, the law of sines, and the area formula using sine. I'm going to give the proof of these and when to use them and basically how to use them. Alright, so first I'm going to prove the area formula. Here we have a non-right triangle, but I've split it down the middle. I've made it an altitude or a height, and it's now two right triangles. This here is 90 degrees. First I'm going to label the sides and the angles. Angles are always capital letters, and then the sides, the opposite side is the same letter but lowercase. Now, so we know the area formula of a non-right triangle, or any triangle. That is that area, don't get these two confused, equals 1/2 base times height. However, we don't know the height. We know the base is b, conveniently, so we can just keep that the same letter. But we don't know the height, and so we're going to try to find the height. So we know that this is a right triangle right here, and so we can use sine. So we don't know what this is, because this didn't split the base evenly. And so we're going to use the side A. So sine of angle C is equal opposite over hypotenuse, SOHCAHTOA, h over A. And so height is equal to side A times sine C. We're just going to pop that into this equation. Area equals 1/2 base, or B, times A times sine of C. Because this whole thing right here is equal to height. We just substituted it. And that is how you find the area formula. And so all you need to do to find area is you need to know two sides and their included angle. You can also do the reverse, all you have to do is have one variable. If you know area and say two sides, you can find the angle. If you know one side in the area and an angle, you can find that side. It's pretty cool. And then of course, once we learn the other equations, this law of sines and law of cosines, we can use that and this equation, or those two equations, to make a system of equations. And then that is how, obviously, you solve for when you have multiple unknown variables. Alright, so that one, the proof wasn't too difficult. We're going to go into law of sines, which I think is the kind of the middle ground of these three equations. So, of course, we always draw our triangle, and we're going to just drop an altitude. And we're going to label it, and then we have h. So, really, the big thing with finding these equations is you gotta find h. And law of sines is a relationship between angles and sides, or the relationship between ratios between angles and their opposite sides. So, first thing I'm going to do is I'm going to find h in terms of this angle A, and then, of course, whatever sides I need. So, h over c is equal to sine of A. And so I know that h equals sine of A times C. Oh boy, I'm getting kind of low on the board here. H over A, we did this last time, equals sine C. And so H equals sine C times A. And so now we can set these two equal to each other. Sine A times C equals sine C times A. Oh, whoops, that should be lowercase. Oh, yep, they both should be lowercase. And now I'm just going to divide by the sides. Sine A over A equals sine C over C. And then this is the relationship that we wanted. We know that the ratio between the sine of an angle and its opposite side will always be the same. You can also rewrite it the opposite way. If I divided by the sines, C over sine C equals A over sine A. That's also used. Although this one is a bit more conventional, and the way it was explained to me is that the denominator is often more complicated than the numerator in people's minds. People prefer the numerator. And so when we put the complicated stuff in the numerator, it makes it kind of easier to grasp. And so since it contains two sides and two angles, all you need to know is one side, its opposite angle, and then another angle and a side. So like if I have an angle, say A, and its opposite side A, and then I have angle B, I can find the side B. If I have side B, I can find angle B using this ratio. Alright, so the last formula we're going to do is the law of cosines, or the cosine rule, which I think is the most fun, but also the most difficult to prove. We're going to start off the same way we started all of them, by drawing a triangle. And then we're going to drop an altitude, h, and then label all of the angles and sides. Now, I'm also going to label two new lengths that we haven't labeled before. And that is the two sections of length B, or the base, which I'm going to call x and y. The first thing that we're going to do is we're going to use the Pythagorean theorem, or the ABC rule, to make some equations. First, I'm going to do the Pythagorean theorem of this triangle, and then I'm going to do it of this triangle. So a squared equals y squared plus h squared, and then c squared equals x squared plus h squared. And this is going to be our system of equations that we are going to use to create our law of cosines. However, I don't want these x's, y's, and h's. I want it in terms of a, b, and c and the angles. So I'm going to get to these in terms of a, b, c, and the angles. So first I'm going to find y, and I know that cosine of c is equal to adjacent over hypotenuse, y over a, and so a cosine c is equal to y. Conversely, x is equal to b minus y, and so I can substitute that in for y, and it will be equal to b minus a cosine c. Finally, h over a is equal to sine of c, and so h equals a sine c. I'm going to substitute those in right here. Since this is a system of equations, I'm going to use substitution to make one equation, and I'm going to isolate a sine c squared. I'm going to treat it as if it is a variable. And why did I choose to isolate this? That is because this whole thing is present in both equations, so it'd be really easy to just substitute it in. Now I can substitute this in to this equation. Now we're going to distribute out these binomials into quadratics. Alright, so now I'm going to substitute this expression right here into this equation. And now I'm just going to factor out these binomials, going to distribute them into quadratics so that they are easier to work with. Now that's a little bit messy, but here we have c squared equals b squared minus 2ab cosine c plus a squared cosine squared c plus a squared minus a squared cosine squared c. Whew. We can simplify this. This right here and this right here have the same magnitude, but they have opposite signs. This is positive, this is negative. Therefore, when you add them, which we are doing, they equal 0. We can cancel this out. So now, when I rewrite the equation, c squared equals a squared plus b squared minus 2ab cosine c. And that is the law of cosines. This is used whenever you have two sides and their included angle, AB and C, or we can rewrite this as C equals the inverse cosine of A squared plus B squared minus C squared over 2AB. So if you have all three sides, you can also find any of the angles, which is very nice. That's an interesting trait of the triangles, and that is why triangles are so strong in construction, because three sides can only make one triangle. It won't distort but maintain the same sides. It will always have the certain angles that it has for those sides. And yes, so though that is pretty much core 9. That's what I'm going to address with core 9. Thanks for watching.